Okay. So we've looked at dividing a bit. 74 for the third time. All right. So, is it 73? Oh, 73. There you go. So, dividing radicals. We've looked at dividing before in that if you have a single term under the radical sign, you can break it up into two separate terms. Okay. Or if you have two separate terms, you can make it a single term. So, for example, root 30 over root 6, we can write it as root 30 over 6. What's 30 divided by 6? 5. So it's just square root of 5. Okay. Even if we have a number in front, a coefficient in front, we can rewrite this as 8 over 2, and the 21 and the 3 are under 1 cube root sign. 21 divided by 3, 7. So, and 8 divided by 2 is 4. So we get 4 cube root of 7. Okay. Let's do the next one here. 15 over 10. What is 15 over 10 reduced to? 3 over 2, because 5 goes into both. So you get 3 over 2. 48 divided by 6. 8. So I get this. But we always have to simplify. Can I break this down any further? The 8 is a 4 and a 2. 2 and a 2. So I can pull out a 2, right? So I get 3 over 2 times 2 root 2. What happens to the 2's on the outside? They cancel out. Or you can go 2 times 3 is 6, divided by 2 is 3. So I'm just left with 3 root 2. Okay, so this is all stuff we did before. Okay? What if, when you're dividing, they're not divisible into a whole number? So for example, 54 divided by 8, what's that on your calculator? 6.75, so it's a decimal. So we're not going to deal with that. What we can do is to rewrite the 54 and the 8. Always reduce, just like we did with the multiplying or the addition. You reduce what's inside or the radicand before you perform the operation. So 54 is 9 and 6. That's 3 and 3. So I can pull out 2 3s, right? Or 1 3, sorry. Pull out 1 3. So I got 3 times 4 is 12. Root 6 over, what can I pull out of the denominator? I'm going to pull out a 2, right? So that I get 2 times 3 is 6 root 2. What's 12 divided by 6? 2. What's root 6 divided by root 2? Root 3. So that whole thing simplifies down to 2 root 3. Okay, so if they're not divisible, reduce the radicand, and usually, because all these questions are rigged, they will be. Okay? Like these two to this point? Yeah, but then it's 3 times 4, the number that was there. Yeah. And then the bottom, yeah, okay, I see what you're saying. So you pull out a 2, and then just multiply it by what number's outside. Okay? We'll do C. Well, because there's a 3 and a 2 left inside, so I just multiply them back together. All right, C. Break down the 162. 27 and 6. 9 and 3, 3 and 3. I'm looking for groups of 3. So I can pull out a 3. 3 times 10 is 30. Cube root of 6. 128. I'll make it easy and just go 64 and 2. 8 and 8. 4 and 2. 2. It's a lot of 2s. So I'm looking for groups of 3. So there's 2 groups of 3 2s. So I can pull out 2 2s, which is 4, times the 20, which is 80. Cube root of 2 is the only thing left inside. What's 30 over 80 reduced to? 3 over 8. Just drop the zeros. Root 6 divided by root 2 is root 3. Cube root of 3, I guess we should be. Okay? All right. So, what if you have something like this? So you have a choice. You could try to combine the tops, but if you have a single denominator like this, one term, it goes to each one. So this can be rewritten as root 24 over root 6 plus root 48 over root 6 minus root 108 over root 6. What's 24 divided by 6? So I get square root of 4. 48 divided by 6. 8, not 18. Wow. And then 108 divided by 6. That's 18. Correct? Okay. Oh my gosh, I just wrote 108 in. 18. There we go. Okay. Now we just need to clean it up. Simplify. What is square root of 4? 2. The 8 we can rewrite as a 4 and a 2. 2 and 2. So 2 root 2. And the 18, 9 and 2, 3 and 3, plus minus 3 root 2. So the only thing I can combine are these ones. So I get 2 minus root 2. Is that okay? So when you're dividing, you could have simplified each one on the top and then combined them together if they do go together. But because when you divide, the numbers are going to get smaller, it usually makes more sense to just divide them first like this and then break them down after that. Okay, because the numbers will get smaller. Whereas when we are multiplying, the numbers are getting bigger. So simplify first before you multiply. No questions? All right, I would like you to do numero number 2, pick 3. Number 3, pick 2. How's that? Number 3, pick 2. And number 4, pick, no? A to ABF. No. Yeah, ABF. Number 4, A, B, and F. You can always do all of them if you need extra practice, but I'll give you time to work on those ones. We got a bit more to do in this lesson, and then the next lesson is very tiny. We'll either finish it today or tomorrow, but I'll give you 15, 20 minutes to work on those. If you have a question that asks you to rationalize the denominator, what it means is, okay, you cannot have any radicals in the denominator. You need to get rid of the radicals. We're only going to deal with square roots in this class, so no square roots in the denominator. That's what rationalizing means. Okay? You can only have whole numbers. So we need to get rid of all the square roots here in the denominator. How do you get rid of a square root? You square root it. Or sorry, you square it. Okay? But you multiply by the square root again, which is essentially squaring it. Okay? Because if you have a square root, I'll just say x. And one second. Hello. Yes. Okay. Okay. All right. And you square it. We talked about this at the beginning of class. A square root means to the power of a half. So if you're squaring it, 2 times a half is just 1. Right? So when you square a square root, you're just left with what was inside the square root. That's it. Now, what number can you multiply by that doesn't change anything? 1. So what we're going to do is we're going to multiply by a radical, by a square root, and we're going to rewrite it as the number 1. So what that means is if I'm going to get rid of this root 13, I need to multiply by root 13. But that's going to give me a different answer if I just multiply the denominator. If I have 1/2 and I multiply by 3 in the denominator, right? I get 1/6. Everybody agree with that? 1/2 and 1/6 are different. But if I multiply by 3/3, I get 3/6, which is 1/2, right? This is 1. Any number divided by itself is 1. Okay? So the trick is you're actually multiplying by 1. We're just writing it in a different form. Okay? So if I'm multiplying the denominator by root 13, I need to multiply the numerator by root 13. Because we're not changing the value if we do that, because that is still 1. All right? This gives me, the numerator becomes root 13, because it's just root 13 times 1. What's the denominator become? 13. That's your answer. It's rationalized. As long as there is no square root in the denominator, it is rationalized. Now you always want to simplify. Can you break 13 up into anything? No, it's prime. So we're done. Okay? B, what am I multiplying by? Top and bottom. So what does the top become? Root 10. And the bottom is? Can you break the 10 up? No, we're done. C, what am I going to multiply by? Negative root 6. So what does the numerator become? Negative root 12. What's the denominator become? Positive 6, right? Because it's negative times a negative. What do you always need to do? Simplify. That's a 4 and a 3, so I get Negative 2 root 3 over 6. Can I break that up anymore? Or reduce that anymore? What's negative 2 divided by 6? 1 over 3. Or negative, yeah. So this becomes negative. Okay. That one, there was another way you could have done it. And because if you look at the numbers being divided, are 2 and 6, like, can I reduce that? You can, right? So if I go over here and do it, and I'm going to go root 2 over 6 is that, right? Which is then root 1 over root 3, which you can't really see. What's the square root of 1? It's just 1, right? So you don't really need to write the square root. So really what we have is 1 over root 3. And then you could rationalize that by multiplying top and bottom. So you'd get root 3 over 3, which is, and there was a negative in there somewhere. Negative, 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 which is the same thing we have over here. So if you want, you can reduce it first and it makes your life a little easier, or somewhat. D, is 20 divisible by 3? No, so we're not going to do that. So I'm going to multiply top and bottom by root 3. What's the numerator? Root 60, and the bottom is just 3. What do we need to do? Reduce. I feel like I'm losing people. 15 and 4. So I get 2 root 15 over 3. Okay, last 3 questions for today. So these 3, and I'll give you some practice, but I'm not going to do any more new stuff. 7 divided by 3 root 7. What do I multiply the denominator by and the numerator? Not just 7. Root 7. You can multiply by 3 root 7, but you only need to get rid of the radical. Okay? So I can just multiply by root 7, root 7. Which gives me, up at the top, what do I get at the top? You get 7 root 7, right? Because you can't multiply that 7 in because it's not a radical. The bottom becomes what? Times 7, because if I multiply those together, I get, here, I'll write it out. I'd get that, which is then 7 root 7. Square root of 7 is 49. Or sorry, square root of 49 is 7. Reverse that process. And I'm not going to multiply the 3 and the 7 just because, well, you can. You'd get 21, but those are going to cancel. So you get root 7 over 3. Two more left. 18 over 5. That is the same as root 18 over root 5. What am I going to do? Sorry? Top and bottom by root 5. So the top becomes 50, 40, 90 over 5. What do you have to do? reduce it, 10 and 9. So I get 3 root 10 over 5. And the last one, root 12 over root 72. These are bigger numbers. I don't want to multiply by root 72, but are 12 and 72 factors of each other? So reduce it. Because I can rewrite this as this. 12 over 72 is 1/6. So it's like 3 over root 6. And then do it. Root 6, root 6. 3 root 6 over 6. What does the 3 and the 6 reduce to? 1/2. So root 6 over 2, or if you prefer, 1/2 root 6. Those are the same thing. All right. Your question is number 5. I said I was going to give you a quiz tomorrow. I'm not going to. Finish number 5. I'll go over the quiz from yesterday.